Good morning. Good morning, everyone. Welcome to the Green Blueprint webinar. Thank you for joining us for this session. Okay, so we will start now with a full list of interesting and insightful presentations. My name is Raquel. I will be the moderator for today. I work as a project manager at F Success, and we are hosting this webinar as a joint collaboration between 9 EU-funded projects to show you how we're investing in a nature-positive economy for Europe. So we will be showcasing 9 projects from different areas, different topics, and showing how all of these are contributing to making a green blueprint. So moving on, let me just adjust here. We will start with a presentation by our keynote speaker, Brian Norton, who is an emeritus professor of solar energy applications at TU Dublin, currently a president of the European Sustainable Energy Innovation Alliance, and vice president of the European Academy's Science Advisory Council. His research on the applications of solar energy, particularly in the context of buildings, has led to innovations in photovoltaics, glazing, daylighting devices, and solar water and air heating. He is particularly associated with conceiving and developing the use of phase change materials to cool photovoltaics, and with patent and commercialized innovations in vacuum glazing and thermophotovoltaics. Brian, would you like to join and start your presentation, or maybe say something to welcome also the participants here with us today?
Thank you very much, Raquel. And indeed, good morning, everybody, and welcome to the presentation. I'm going to talk about how do we invest in our resources to protect the planet while driving economic competitiveness. So that's a very, very large topic. So what I'm going to focus on is some selected examples from research on energy use in existing buildings, and really perhaps set some of the context in terms of the parameters, the wider parameters that one needs to consider. If I could go to the next slide, please. A little bit of provocation to start with. Buildings do not use energy. Energy use is not a building's purpose. Now, for many people, that would be a heresy. But if I go to the next slide, it explains what I really mean. And that is that buildings don't use energy, their occupants do. If there were no people in the building would not need energy. It's we, the occupants, that need energy. And that energy use is not there just to consume energy. It actually is there to provide amenity and health. So immediately the contextualization of energy is around people, is around amenity, and it's around health. And this is part of a much wider dimension for all basic human needs, whether it's air or water. There are 3 dimensions that one needs to consider. That it's sustainable in the long term, that it's affordable, and that brings a whole lot of economic aspects to it, and that there is a security of supply, there is resilience, and so that you know that today you're going to get it and the next day you're going to get it. So these attributes of occupants using energy and the amenity and health use of it in buildings is much of a part of a wider spectrum. So if we generalize that, if we go to the next slide, you see amenity and health sit within a dimension of decarbonisation, which is one representation of sustainability, particularly in the built environment context, that you want to reduce the carbon impact of the building, affordability, and resilience. So they overlap, and the successful achievement of amenity and health is where those things are in harmony. And the challenge often is that perhaps one focuses on one aspect, affordability if you're looking for economics aspect, resilience if you're looking at geopolitics, for example, or decarbonisation if you come with a very strong green agenda. And if you forget the other 2, that's when things begin to fall apart. So if we go to the next slide, that means that if you look then at the much broader things there, decarbonisation includes obviously energy refurbishment of buildings, use of renewables, embodied carbon, Both it and affordability relate to energy policy and indoor air quality. That's what the IAQ is there. The daylight that comes into buildings is part of affordability, carbonisation, but also part of resilience. And resilience has a whole lot of things to do with climate resilience in itself, which strongly overlaps, of course, with decarbonisation, with market structures, and with national energy security. And from an affordability perspective, you've got both issues of energy poverty, where if more than 10% of the disposable income of the energy consumer is spent on energy, that is the definition of energy poverty, fuel poverty, as it used to be called, and also a very strong set of issues to do with quality of life. So in looking at the problem, one can't just take one of these aspects, one needs to take all these aspects together, and that can get very, very complicated. So if I go to the next slide, what I'm going to do is take some more of these challenges in a bit more detail. And you'll notice on the slide, I've got some various references, usually fairly recent papers, that go into these topics in much more detail if there are people who want to follow up accordingly. So if I could go to the next slide. First of all, I think the issue, particularly with buildings, is fundamentally a data and understanding the data. No national government measures all the energy consumption data of every building in their jurisdiction. Just isn't done. Now, you could argue that perhaps utilities know that from gas bills, electricity bills, but what they know is the energy supplied to the building, not how much energy is actually used in the buildings, and how that use disaggregates into heating, lighting, cooling, use of appliances, etc. So in terms of national energy policy, in terms of interventions they're made in the building sector, energy rating statistics are used. And energy ratings were originally done as a mechanism of ranking buildings to a particular standard for the ability to distribute grants to improve their efficiency. They mistakenly are sometimes sought to represent the actual energy consumption of a building, and they don't, because they don't take account of occupancy, they don't take account of climate, and there are huge numbers of simplifications made in an energy rating context. So you see the big chart with all the colours there, and the little bits of the green at the bottom of this is a little bit out of date now, but a little bit of green at the bottom is the A-rated buildings, the high-quality buildings. So what this tells you, two things. A is there are very few A-rated buildings. There's a large number of red there, which is essentially buildings that need refurbishment, need to be improved. So there's a large activity in trying to improve the energy rating of buildings from the red to the green on that graph. But interestingly, it doesn't always achieve that, and the reasons are complicated. You can see with the two graphs on the left-hand side there, and that is that existing buildings, which the rating system would be saying were very poor, often are not quite as poor, because the rating assumes the building has largely remained in the same state in terms of its fabric as when it was originally built. And in fact, most buildings are improved, they're better insulated, new things are added, new doors, new windows, etc. So their energy performance is better. Okay, so when you improve it, you don't get as much energy performance as you might assume, because people have improved their buildings over time. At the other end of the spectrum, people get disappointed that very energy efficient buildings are not as energy efficient as they should be. That's because, and it's a very common paradox in many things, that the consumers take the benefit of the official energy rating by heating the building to a higher temperature, or if you're in a heating dominated climate, or if you're in a cooling dominated climate, cooling it to a lower temperature. In other words, they take the benefit in other forms, so that at both ends of the spectrum, the actual energy rating of the building, the actual energy performance of the building, because of human behavioral factors and the way people relate to the building, either in improving it or in operating it, are different from how the building should perform. Now go to the next slide, please. And then I come to another topic, indoor air quality. Now, this came about in the COVID-19 pandemic, that there was a reassessment of indoor air quality. A lot of energy use in buildings is basically heat gains and heat losses through the building fabric, but also heat losses through ventilation infiltration. And over the years, increasingly, buildings have become more and more airtight, and that has led to indoor air quality issues. And they came to a head in, as I say, COVID-19 pandemic, where suddenly it was realized that actually you need to have quite a large air change rate to dilute the quantity of bacteria, viruses, etc., in the atmosphere. That has led to much more attention now being given to how you you either preheat ventilation air, or as the example I show here, do a lot more work on ventilation, mechanical ventilation, heat recovery, and recirculate warmed air back into the building. And so again, looking at pure energy context would say, right, have airtight buildings. Looking at it from a broader people, health, immunity context would indicate that you would need to have higher air change rate, but either do something to preheat the ventilation air or to recover it as it's left the building. Then let me give you another, perhaps more surprising example. If we go to the next slide. And that is daylight. And daylight is very important for human beings. It's obviously provides visual amenity. You can see things, etc. in daylight. But also it's critical to the eye development of children. And if you don't get that, that causes myopia, short-sightedness consequences. Very important for bone health, the immune system. The near-infrared part of the spectrum does that very well. Parts of the green part of the spectrum are very important in terms of circadian entrainment, our body clock, and making sure that that's healthy. And there's a whole lot of activities to do with our psychological health that come from daylight. And this has been long known. Daylight disinfection, the healing daylight, as you can see here, have largely been part of architectural movements in the early part of the last century. And there's a lot of technologies to project daylight deep into rooms and ensure there is adequate daylight. But interestingly enough, we've seen the replacement of incandescent bulbs with LED lighting, and LED lights do not emit the spectrum that provides the particular spectral lines necessary to promote circadian health. We have low E glazing to prevent heat loss through windows, and they cut off the wavelengths that provide near infrared that is good for bone health of the immune system. So again, there are conflicts between the health aspects of daylight and some of the interventions that one makes in the buildings to reduce energy efficiency. Now, there's solutions there. There are solutions in terms of selection of the glazing material, that all glazing doesn't need to be low emittance, in how the building is designed so that you can allow, given weather, time, other things, that people can actually go outside and get exposure to daylight there. But needs to be looked at from a systems perspective, and what again is the particular occupants of a building, and particularly with school buildings and children and eye development, they become particularly imperatives to get adequate access to daylight. If I could have the next slide. And then, of course, one of the key things that's happening is building refurbishment and building renovation to reduce energy use, and a whole lot of things of improving insulation. At this building, particularly is in Estonia, by the way, for those who might be familiar with it. Balconies become rooms, volumetric addition, reducing loss, heat loss windows, etc. So the whole mesh to do with energy refurbishment of buildings. If I go to the next slide. But one of the challenges here is that refurbishment itself has embodied carbon. There's carbon, there's energy embodied in the materials you've used to refurbish the building. And ironically, your refurbishment has reduced the operational energy use, but it's actually increased the embodied energy. Now, how much it does so depends on materials choices, whether you want to use recycled materials, the extent to which there's new materials, steel, glass, concrete, that have required high temperature processes and have very high embodied carbon, for example. But there is a time by which the operational energy saving will eventually recoup the additional embodied carbon, and that's what the graph on the right there represents. So there's an imperative to make sure that the embodied carbon content is as low as possible in the design choices, in the component selection, so that payback period for the operation is as short as possible. So again, that refurbishment is good, but there's a trade-off between it and the embodied carbon associated with refurbishment. I can have the next slide. And the final one of my examples relates to energy poverty. And here, again, it comes down to market structures. Surprisingly, perhaps, in most jurisdictions in Europe, at some point in the year, renewable energy generation is actually curtailed. There is renewable energy that could be produced, but there's no market for it. And so literally, the utilities do not buy what the renewable energy generators are producing. And that's seen through a market lens. But if you looked at it from a poor consumer's lens, if they could use that energy, if they could alter their behavior as a demand side measure to use that energy, or that energy could be stored, it could alleviate fuel poverty. And one proposal here, and you see the reference that's presented there, is that actually you give away that energy for free to allow people to produce hot water, to allow them to bath their children, etc., which has a huge saving and has benefits to the grid that you're now using that energy there, obviously to citizens, obviously supports the climate, and also provides a much more inclusive society from a state perspective. So again, not necessarily looking at the existing market structures as being inviolate is important, looking how you can change these things. Then if you go to the next slide, please. So to conclude, there are many factors, there are many benefits, but there are disparate beneficiaries. And that often is the real challenge here. And as you can see, I won't go down through all the detail of the graph on the left there, but many, many aspects need to be taken into consideration. And then we can have the next slide. So what are the key requirements for reconciling health, immunity, decarbonisation, affordability, and resilience? And as you see from the presentation, there are many others. But if you wanted to distill down what are the key requirements, and then I can have the next slide. So in practice, I think it is inclusive, holistic, user-centric design. You start off from the user's perspective and work outwards. Not, for example, in buildings from the energy perspective, but from the end use perspective. And also then do quite a structured likelihood and impact risk analysis. What's the likelihood of something happening? What's the impact of that? So you have then a ranking of things that you need to deal with. And to be able to deal with that, disciplinary perspectives are important, and the disciplinary perspectives of a heating engineer, of an architect, of a planner are quite different. So you need to have a genuine interdisciplinary team. What I mean by genuine is that everyone's views are heard and taken on board. So that's in practice. In research, and I know we have a lot of researchers on this call, I give three, there are many requirements, the three key requirements. An awareness of what I would call tacit assumptions, not the assumptions you've consciously made, but the assumptions you've unconsciously made about market structures, about human behavior, or even the importance of human behavior, etc. So beware of the tacit assumptions you made and write them down and think about their validity. And then linking with that, avoid inappropriate artificial boundaries, context, limitations. Don't say, I'm studying the market structure of this, or I'm studying the energy impact of this. You need to study it from the natural perspective of the end use that emerges. So avoiding artificiality of context, which can be a disciplinary context. I study the physics of it, the biology of it, etc. No, study it in the end use context. And then finally, and linking the other two, is communicating honestly. All things have limitations, all things have contexts, and making sure that those limitations of context are communicated to the end user enables the end user to better use your research and avoid its misapplication. Thank you very much. We go to the final slide here. Happy to answer questions. Thank you very much indeed.
Thank you, Brian. Thank you for accepting our invitation and for joining us here today, and for your insightful presentation. It was lovely to have you here with us. So I'd just like to invite the audience, if you have any questions that you'd like to ask to Brian, feel free to please write them on the chat, and our team will be checking those, and at the given time we will go over the questions, and then we will allow some time for discussion and also to answer all your questions. Okay, so this being said, we'll be moving forward to the next presentation. So this webinar today will be split into three different sessions, and each session is focused on a different pillar. Okay, we'll start with the first pillar, the living landscape, and we will present to you three different EU-funded projects, all related to tech-enabled restoration and smart land use. Okay, we will be starting with INO for CFIs, and with us we have Julia Burney, who will be the speaker on behalf of the project, an agronomist and project manager at Planet. She's involved in the implementation of European innovation projects addressing sustainable water management and agriculture, combining expertise in environmental biotechnology, statistical data analysis, and field implementation. She works on the development and validation of the mangrove technology platform, an innovative solar power desalination solution in water-scarce regions. Hi, Julia. Good morning. Thank you for joining us. Would you like
Thank
to
you.
jump in now?
Yeah, thank you. Thank you very much. Indeed, like I'm Giulio Berni, and I'm work for Planet, an Italian SME who is responsible for the technical integration of the Inno4CF5 project. You can go to the next one, and I will briefly present this I3 project supporting innovations for carbon farming initiatives. The aim of the project was, in fact, to support green tech innovation for regenerative agriculture while preserving water, soil, and biodiversity. The project is led by Fondazione Amaldi and is composed by 21 partners from different 14 regions. And in the next one, you can see, in the next slide, you can see that it's SMEs, university and research institute and organizations from Mediterranean and continental Europe. The main objectives of the project, you can see it in the, were twofold objectives. Like indeed the creation of a carbon farm technology platform, and that's what I meant with the green tech integration of the partner technologies to support tree planting in different regions, and the acceleration of the European innovation ecosystem by indeed accelerating SMEs and startups and advancing them in their development. And next one, please. Concerning the first objectives and the carbon farm technology platform, indeed, it's like imagine as a system, a modular platform integrating the different technologies and different services that I'm gonna show soon, to tackle the specific challenges, environmental challenges that Europe may face in supporting regenerative agriculture, agroforestry, and carbon farming. And you can see the next one that the partnership and the consortium covers different technologies for water and soil management. There were testing and validation of nature waste rainwater harvesting system, desalination system in order to have, fresh water available for the irrigation. And then the consortium also worked with mycelium, both for micro-remediation of contaminated soil and as well like in micro-based material for bioincubator to support the seeding growth after transfer. So we have like enabling technology, managing water and soil for the agroforestry plot. And in the next slide, you can see that also the consortium covered everything concerning to the data provisioning. So sensors, remote sensing, satellites, drones, and in situ app to collect and monitor data, and also in the end to gather them in an overall data space where each partner maintains the ownership and control on the data. And moving on, you will see that indeed like all the data collected, especially considering not only carbon but also looking at biodiversity, soil and water, they represent an interesting opportunity for farmers and landowners. And the project implemented a peer-to-peer platform where actually it's possible to tokenize and to exchange the data produced and issuing smart contracts. And finally, concerning and going back to the the second main objectives of the project, the consortium supported and accelerated SME and startups, but also created the interregional market uptake hub that you can check in the link I'm putting there. And it's an ecosystem indeed to connect farmers and land users with buyers, carbon credit investors, technology providers, SMEs and startups to really strengthen the connection and make the technology provider meet with the client and with the buyers. Finally, the technologies that I mentioned and the activities that I mentioned were tested in 4 different living labs with 5 locations. And you can see in the final slide that the next one, please, that the different locations where the technologies were tested. We have Italy, Belgium, Greece, and Spain, where according to the context needs and challenges, we tested and validated this different approach to indeed support agroforestry initiatives in Europe. And that's my last slide. Thank you. Thank you very much.
Thank you. Thank you, Julia. So we will move on. We'll go to the next project, Palawise, and we will have some time for questions. So the Q&A after all these three presentations. So before we move forward to the next pillar session, we will give some time for questions. Okay. Thank you once again, Julia. So we'll move to Palawise. And this project will be presented by Christina Lang, a research professor in Natural Resources Institute in Finland, with a focus on sustainable use of agricultural soils. She has studied peat soils for 35 years, including their greenhouse gas emissions and their mitigation, rewetting, and the potential for novel value chains from pallidoculture. Hi, Christina. Good morning. Thank you for joining us. I will now give you the floor.
Thank you, and good morning, everyone. So I will tell about the Palawise project that develops alternative uses for drained peat soils. And the full name is Pallidoculture Demonstrations Providing Multi-Actor Approaches and Recommendations Towards Large-Scale Deployment in the EU. And if you wonder what is pallidoculture, it means that you raise the groundwater table to reduce greenhouse gas emissions, but you select a wet-tolerant crops so that you can also have some kind of productive use for the land after rewetting. And in this project, I don't present the whole project, but I tell about these 4 large demonstration sites. So they all trial biomass production and also monitor the environmental performance of the sites. And the nice thing is that we have companies in the project that develop use for these novel types of biomass. And the next, please. So drained peatlands are quite a problem in the EU. So compared to the natural peatlands that act as carbon sinks, when they are drained, they start to release greenhouse gases because the drainage creates an aerobic layer in the top peat, and then the microbial decomposition causes loss of peat and high greenhouse gas emissions. They are more than 200 million tons of carbon dioxide equivalents in Europe. So quite a problem. And so in this project, we trial to block the water outflow from these sites so that we can have the weather conditions there. We can still have biomass production, but also quite a reduction in greenhouse gas emissions and the other environmental problems like land subsidence, nutrient release, and biodiversity loss. The next tells about the value chains that we trial. So in Finland, the main crop is downy birch on former peat mining site, and there we trial biochar production with its side products like the pyrolysis liquids, and they were trialed as biostimulant in crop production. There we don't have a company, but in the Netherlands the main crop is reed, and it's used for construction material, so both roof thatching and insulation boards by a Dutch company. In Poland, the plants trialed are sedges, and they are used for insulation boards and horticulture substrates. In the UK, the trialed crop is taifa, so cattail or burrush. It's used for grazing and construction, but also for textile industry. So it's the fluff Typha is a perfect filling for winter jackets to replace polyester and down. So there is a company called Ponda using that material. And the next slide shows how the sites look like. So the Finnish site used to be a former peat mining site. The other sites have been in agricultural use, and their downy birch has been established there on its own, but we will also plant reed canary grass and willow. And I told about the biochar value chain in the Netherlands. It's the common reed, Phragmites, that's the crop. And in the next slide, there are the Polish and UK sites. So in Poland, it looks like that, quite wet conditions for sedge growing, and it's a quite new raw material for industry. And in the UK, there are many different kinds of trials in this very large revetted site that was restored already in 2008. But our trial site is this Typha site. So here you can see in the figure, you can see how the fluff looks like when the flower is has bloomed. So that's collected for textile filling. And I think that was the last slide. I just thank you for interest.
Thank you, Christina. Thank you for presenting to us Palo-Wise. Moving on to the last project within the first pillar, Agrimate. So we have Tatiana Bartolomeo here with us today. She has more than 20 years of experience in the development and management of multidisciplinary R&D projects in the ICT field. She currently works at Technalia Research and Innovation as part of the Visual and Multimodal Interaction team with the Industry and Mobility Unit. Her areas of expertise include Industry 5.0, human-centered design, user experience, information visualization, digital skills, e-learning technologies, and adaptive multimodal interaction. Tatiana, good morning, welcome. Feel free to start.
Okay. I think that now you can hear me. Yes. Hello, everybody, and thank you for joining us today. Okay, my name is Tatiana Bartolomé, and today I will try to briefly present the Agrimate project and how we are developing a assistive and autonomous pruning system for high-value crops. Agrimate is an European project focused on improving pruning tasks in agriculture through the combination of artificial intelligence, augmented reality, robotic, and human-centered technologies, okay? So our main goal is not only to improve productivity, but also to support workers, reduce their physical efforts, and make agricultural work safer and more sustainable. Next slide, please. Okay, so here you can see Agrimate combines several advanced technologies to transform the pruning process. First, we use artificial intelligence to analyze plants and to generate pruning recommendations. Then augmented reality provides real-time visual guidance directly to the worker in the field. We also integrate robotic to automate repetitive and labor-intense tasks, especially in the one-year environments. But one important aspect of the project is that technology is always designed around the needs of the farmer. So we can see that beyond efficiency, Agrimate also focus on improving working conditions. We try to reduce the fatigue and support the knowledge transfers between experienced worker and new generations. Things that we have seen that is a very important issue here in this project. Next slide, please. Okay. In AgriMed, we focus on two representative crops, the traditional olive trees and the vineyards. These crops are economically and culturally very important in the pilot regions, but they also present very different technical challenges. In traditional olive groves, for example, trees have very regular shapes, different trunk structures, and offer difficult terrain conditions. So this makes automations much more complex and require highly adaptive artificial intelligence system. For example, in contracts, vineyards are more structures because vines grow along trellises. So this creates a more controlled environment where robotic systems can navigate more easily and identify pruning points with higher precision. So we can see that by working in those two very different contexts, we try to demonstrate the scalability and the flexibility of these combined technologies. Next slide, please. Well, in this slide, show our vineyard pilot located in Sparta, in Greece. Here, the project focused mainly on autonomous robotic pruning. The robotic platform combines a perception system, artificial intelligence models, navigation modules, and robotic manipulators to analyze the vines and perform pruning operation automatically. The vineyard environment is ideal for testing this robotic solution because of the organized row structure. So the system can identify branches, detect the pruning points, and execute the cuts with precision. What also we try to collect valuable environmental and operational data. And at the same time, this pilot helped us to evaluate how robotics can support workers and improve consistency and productivity in the viticulture. Next slide, please. Well, here we can see the second pilot. This pilot is focused on the traditional olive groves in Jaén, which is an area on the south of Spain. Unlike vineyards, olive pruning is highly dependent on expert knowledge and human decision making. So trees can have very different shapes, size, and growth patterns, and especially in the older one. So this is why AgriMate follows an human-in-the-loop approach. The artificial intelligence system learns from the expert planners by analyzing their planning decision and techniques. Then, through augmented reality glasses, the system visually guides the farmer in real time, and virtual indicators are projected directly onto the tree, showing where pruning cuts should be made. This is especially important because one of the main challenges identified during the project is the shortage of skilled agricultural labor and the progressive loss of traditional expertise. And this way, the technology acts as an intelligent assistant that supports workers, but without replacing them, helping improving quality while also facilitating training and knowledge transfer. Next slide, please. So to conclude, AgriMate more or less explore how artificial intelligence, robotic, augmented reality can contribute to a smarter and more sustainable agriculture. Our goal is to develop technologies that are not only technically efficiency, but also practically accessible and useful for real agriculture workers. So that was more or less the information that they want to share with you. So thank you very much for your attention. And if you are interested in the project, you can see more information through the code shown here. And okay, that's my presentation. Thank you very much.
Thank you, Tatiana. And thank you all to the three speakers that presented to us these three European projects. So this is the end of Pillar 1 session. We'll shortly move forward to the next one. Before, as promised, we will now allow some time for questions. And I can see here that there's already some questions in our chat. There was one. Oh, sorry, let me just go here. So there was one here to Brian. I think I will start with that one. Or okay, no, I see that Brian, you have already answered in the Q&A. Thank you for that. Not sure if Summit would like to follow up on that. And then we have some questions here now for Paulo Wise speaker. And Christina, you have also answered. Okay, so thank you. If there's any more questions from our participants, please feel free to include them in the Q&A, and the speakers can do it as they've done so far. They can follow up and reply to directly on the Q&A or the chat, or we can also take the advantage of this Q&A time that we have for discussion and answer them here. So before we move forward, I would like just to ask a couple more questions to our speakers. So speakers of INFERNO, Paulo Wise, and AgriMate, to have just a brief discussion to close this first session. So now looking at your presentation, so we've seen here three approaches to land use, right? From carbon farming and wetland restoration to AI-driven precision robotics. How can these three distinct solutions be integrated on the ground?
Okay, I don't mind. I could start. So I think that those projects are really brilliant projects. So I think that the key message is not is that those are not competitive solutions. I think that they are complementary. So carbon farming helps improve soil health and carbon storage, wetland restoration, so where ecosystem recovery and water management should be prioritized. And in the agreement, with using artificial intelligence driven tool, we can make the land that remains in production more precise, efficiency and sustainable. So from our perspective, our contribution in those productive areas, especially in the crops like winegard and olive groves, where pruning is highly skilled and more intense. So I think that we can focus in this three projects in different areas, but for sure that we can collaborate in somehow in some information in the necessities of the end user is something that we have started seeing with the Brian presentation that he had explained us that we should focus on the real needs and on the real uses. So it's what I think that these three projects we try to do, more or less.
Yeah, and if I may add, indeed, like I think that first, as you say, like technological integration, because I mean, for example, like in INFERNO, like 3 sites, 3 living hubs were in Spain, Italy, and Greece. So indeed, like in the agroforestry plot, olives was one of the species present there. So indeed, like there is like a complementarity there. And then I may add that indeed, like one of the objectives of INFERNO is like to reinforce the innovation ecosystem and indeed to put in contact and to support farmers and land loan owners, also like in a network with indeed like technology providers, innovation actors, and with the platform, like it's open, so like the integration could also happen in that level and in the data management then and exchange.
Thank you, Tatiana and Julia. I'm not sure if Christina would also like to add something.
Well, I can say at least that actually in the EU terminology, peatland rewetting is a part of carbon farming. So it's just that we need the specific solutions for each farm, each region, each field even. I'm sure that every field plot in the EU can improve its performance, its environmental performance, and there's no one silver bullet that solves our problems. I think we need these different solutions for the different conditions. So we need all of these aspects in our research.
Thank you, Christina. So just one more question before we move forward to the next pillar. So we've seen that all three projects have both technological and ecological potential, right? Shifting traditional land use habits is always a challenge. From your respective project experiences, what is currently the biggest barrier to getting farmers and landowners to adopt these innovations?
Well, if I can continue, peatland rewetting is maybe the most difficult land management change for landowners because drainage is done for good reason. Then the field plot carries heavy machines, or not all farms can just go to paludiculture because they have too large machines for the fields. There should be also services as contractors doing the harvest in the wet fields, and of course starting from the conventional subsidy system. In many cases, it's easier just to leave the degraded site uncultivated than to convert it to productive paludiculture, because you can get subsidies even without this kind of biomass production. So there are these practical challenges. Not water is available everywhere. The local conditions, local regulations are very different in different countries. And then there are the psychological factors. If the grandfather drained this soil with a shovel by hand, it's it's a question also, who is the brave person that then converts this and rewets the site that has been drained with such a hard work in the history. So many things affect.
Well, yes. From my point of view, the biggest barrier is the confidence. Farmers need to see that an innovation is not only promising in theory, but also useful. It must be affordable and realistic in their day-to-day conditions. So they want to know whether it fits their farms, whether its support if something goes wrong. So that's something that we also see very, very clear in the AgriMate. Adoption, it's much more likely when technology is designed around real user needs. So it's not a replacement for farmers. It's a support for them. That is why we have tried to follow the human-centered approach, focusing not only on the efficiency, but also on worker conditions, skills, and usability in the field. Because when we have been talking with the farmers, we have been learning about them. Some of them were very reactant to the use of this technology, especially the older people. So we try not to convince. We must show the possibilities that this technology offers and explain them the possibilities. So for us, is the confidence the main barrier, for sure.
Indeed, just to briefly connect, like I was about to say, the uncertainty that actually the technologies or the solutions might improve not only sustainability, of course, but at the same time productivities, or at least that they, are able, of course, to ensure stable productivity. And that's, I mean, what we, I think all of us is trying to do, like to test and to show them, to make, I mean, in the end, some tools like closer to the users and to make them more accessible and easier also to evaluate according, as you said, like to their own context and their own standards. As we're seeing now, we're all, I mean, working on tailored and solutions tailored to the specific users. But yeah,
for sure, yeah.
Thank you all. Thank to all three of you for your input and for sharing that with us. So with this, we close the first pillar discussion, and we'll move forward to the second one, the circular built environment, where we'll be focusing on sustainable materials and intelligent resource loops. So again, we'll have 3 more projects presented throughout this session. We will start with SNUG, and this one will be presented by Joanna. So we have Joanna Berdenoffer here with us today. She's the founder and CEO of TEG Services. She studied mathematics in Vienna and brings deep expertise in aeronautics and green technologies, sustainability, and strategic policy. Her work focuses on connecting technological innovation with sustainable and forward-looking strategies. Joanna.
Thank you, Raquel, for the introduction. Hello, good morning, everybody. I'm very happy to be here and have the opportunity to introduce you the SNUG project. It's a Horizon Europe project focusing on sustainable insulation for buildings. The next one, please. The overall ambition of SNUG is to support the transition towards climate neutral, resource efficient, and healthier buildings. We do this by combining sustainable materials, circular economy principles, and also by developing an AI-based digital decision support tool. Why we are doing this, as you all may know, about the construction and building sector is responsible for almost 40% of the energy use, the global energy use, and the CO2 emissions, and still many conventional insulation materials are linked to carbon-intensive materials and production processes. And at the same time, the renovation rate in this sector is slightly increasing, but still remains low. So within SNUG, we address these challenges by developing sustainable insulation solutions based on bio-based materials like hemp, circular materials, we use waste materials, and also by digital decision support tool, because the idea here is not only to improve the technical performance of the materials, but also to support better decisions in renovation and construction. And on the right-hand side, you see the expected impact, lower energy demand, CO2 emissions, and overall the sustainable buildings. Next one, please. Here you can see the different types of insulation solutions. There are more or less 4. They are the aerated concrete blocks using less Portland cement. There are self-leveling mortars with phase change materials for indoor applications. The third kind of solution are aerogel insulation boards. Aerogel is very silica-based, very light material, but rather expensive on the other hand. And last but not least, bio-based insulation panels by using hemp fibers and tannin as a matrix. These solutions are closely linked to circular economy principles or through recycled and repurposed insulation materials. As I said, the bio-based resources like hemp for the aerogel we use production waste, and also for the materials and the production processes is the reduced CO2 emissions. And of course, we would aim to develop longer lasting and resource efficient materials. So it is not only a focus on operational energy efficiency, but also on reducing embodied carbon and improving resource efficiency across the whole material life cycle. Next one, please. Within SNAC, it is very important for us to validate our solutions under real-world conditions. We have different demonstration sites in Norway, Switzerland, and Spain to cover different climates, the Scandinavian, conditional, and Mediterranean climate. We cover different building types like domestic buildings and business buildings, and also new constructions and renovation. These validations is very important actually for us because, and also the different climates, because performance, feasibility, and user relevance can vary depending on the climate, depending on the building type, and also the renovation context. And this is of course important for the future market uptake. The next one, please. PrimaTech, we are not only responsible within SNAC for the techno-economic assessment and life cycle costing analysis. The main part is we are responsible for exploitation and IPR management. Therefore, I would like to give you a closer look on the exploitation perspective of SNAC, because it's not only about the technical innovation. Of course, the technical innovation is very important, but it's important to show that we create real impact. This is done by viable business models. This needs sustainable value chains and also clear market pathways. We start with the SNAC innovations. We have the key exploitable results. We have the technical solutions. We have a look on life cycle assessment, the figures and the life cycle costing. And we transfer these information into circular value propositions. It's about clear user benefits and also competitive differentiations. The next step is to assess the business models and partnerships. This includes revenue and licenses models, and also circular value chain partners. I've been investigating in potential partners and deployment pathways. Finally, the aim is to support a strong market uptake and long-term impact through scalable opportunities, sustainable construction impact, and long-term exploitation. It's actually about sustainable market opportunities, to put it in a nutshell. The next one, please. This is actually my final statement. SNAC demonstrates how circular materials, digital tools, and sustainable business models can accelerate Europe's transition towards climate neutral and resource efficient buildings. This is how I would like to close the circle. Sustainable solutions need to be technically credible, economically viable, and accepted by stakeholders. Thank you so much. These, yes, here are the partners listed. Okay, thank you, Raquel.
Thank you, Joanna. Next project is Spur Up, and today with us we have Anthony Peppers, who's an assistant professor at NTUA, specializing in energy and environmental optimization for the metallurgical industry. He has extensive experience in decarbonization technologies and sustainability analysis. Currently, he coordinates 4 research projects with 28 million euros funding, focusing on integrating hydrogen into industry and converting carbon into e-methanol, promoting urban industrial symbiosis. Appointed by the European Commission, he prepares recommendations for alternative fuel pricing in line with EU directives. He also supervises a hydrogen living lab at NTUA, equipped with advanced hydrogen infrastructure and powered by renewable energy, managed by a smart microgrid. Good morning, Anthony. Thank you for joining us, and we're ready to start.
Thank you. Good morning. Thank you very much for the introduction. Today, I will briefly present the SPARA project funded under the Horizon Europe Mission Framework, focusing on climate-neutral peri-urban development. The project addresses a very important European challenge: how peri-urban areas, the transition zones between cities and rural regions, can support industrial activity while also achieving sustainability and climate neutrality. Let's go to the next slide. Why peri-urban areas matter? Peri-urban regions are under strong pressure from urban expansion, fragmented governance, industrial emissions, and resource inefficiencies. These areas are often where industries, logistics, energy infrastructure, and communities coexist. So the SPARA responds to 4 major challenges: the industrial environmental pressure, the fragmented governance, the lack of climate infrastructure, and social vulnerabilities. Our goal is to create a sustainable framework that combines technological innovation with participatory governance. So on this framework, the project aims to integrate net zero technologies into industrial processes, to improve energy efficiency, to promote circular practices, and to establish local green deals connecting industries, local authorities, and citizens. A key strength of SPARA is the combination of technological solutions with digital solutions and digital tools and governance methodologies. We will demonstrate the technology in 3 living labs at high TRL, and we will have also 3 application sites where scalability and scalability will be validated. Let's go to the next slide. In relation to the technical solution, SPARA demonstrates several advanced technologies. These include solar thermal systems for industrial steam production, carbon capture and utilization with synthetic methanol production, industrial microgrids, wastewater reuse systems, and the technology for power-to-X ultra-pure water production technologies, water able to be utilized in electrolysis. For example, the solar thermal technology can significantly reduce fossil fuel consumption in industrial applications, while the CCU platform converts captured CO2 into synthetic methanol using hydrogenation process. This synthetic methanol can easily be adapted in mobility in urban areas and other technologies. So these technologies directly contribute to decarbonization and also industrial resilience. The project demonstrations are distributed across Europe. We have in Greece a living lab based in Thessaloniki in northern country, with participation from the municipality, regional authorities, and industrial partners like Athenian Brewery. In Denmark, we will demonstrate technologies in Aalborg Living Lab. It's a port focused on industrial microgrids and water circularity. In Italy, we have also the Jesse Living Cloud, which addresses sustainable industrial development and governance integration. Our replication sites in Bulgaria, Romania, and UK, ensuring that the developed solutions can be transferred to different regional contexts. Another major component of Sparap is the digital ecosystem. We include technologies, AI-based analytics platform, stakeholders empowered tools, decision support systems, knowledge hubs, verification prioritization tools, and one-stop shop energy platform. All tools support real-time monitoring, participatory planning, policy alignment, and better decision-making for local authorities and industries. Let's go to the next slide, please. So the implementation strategy is structured in three main phases. The project started on the beginning of this year. The first phase will focus on foundational research. The second phase on development implementation, and the last one in the evaluation application. At the same time, the project follows three-tier engagement model. The first tier validates solutions in the limit labs. The second tier involves regional stakeholders and authorities, and the third tier supports broader European replication and adoption. This ensures both technical validation and long-term policy impact. In the next slide, you will see an overall, let's say, infographic of the project. We are describing here all the technologies that will be integrated in the project, how we'll correlate the industries together with municipalities. We'll create a bridge between them in order to be able to reach the KPIs described on the project. We are describing at least 5% CO2 emissions reduction at each one of the living labs, and a lot of list of achievements. And finally, for closing, let's go to the next slide. I want to state that finally Spire brings together a high level, let's say, with deep knowledge consortium, with high expertise in decarbonization technologies, AI and digital tools, water management, circular economy, governance, stakeholder engagement, and LCA sustainability assessment. In conclusion, SPARAP aims to demonstrate that peri-urban areas can become key drivers of climate neutrality by combining clean technologies, industrial symbiosis, digital innovation, and participatory governance in order to have, let's say, a wide public acceptance and to enhance the green industrialization in Europe. Thank you very much for your attention.
Thank you, Antonis. And now to close our Circular Environment session, we have the STRIPE project presented by Mette Kirk. Mette is an Innovation and Sustainability Specialist at Reunitex AS and Head of Development of Fiber Family, Euritex's digital connection and traceability platform for feedstock and recycled materials. Her expertise covers EU regulation and compliance for textiles, life cycle assessments for textile recycling systems, and user-centered design of digital tools and systems. Mette is passionate about turning complex environmental and material requirements into practical, scalable solutions and building collaborative value chains in which recycled materials can compete on quality, transparency, and performance. Mette, thank you for joining us today. We're ready to go.
Hey everybody, thank you. Thank you for having me. As Raquel said, my name is Mette, and I work at Euritex's and an Innovation and Sustainability Specialist. And today I'm really excited to be sharing how the STREP project is contributing to the topic of sustainable materials and intelligent resource loops. Next slide, please. Thank you. So STREP stands for Streamlined Textile Waste Streams for Recycling Optimization. And it's an EU innovation initiative transforming textile recycling through automation, intelligent sorting, and sustainable chemical processes. The project consists of 13 partners across the textile value chain, including sorters, recyclers, universities, research institutions, and technology providers. Next slide, please. Yeah, so some of the STREP methodologies that I want to highlight is it consists of 4 main focus areas. The first being detection and disintegration, where our project partner are developing AI-powered sensors to automatically identify and remove hard parts such as accessories, trims, and also prints. And then going to then we also have design and assembly, where requirements are collected to optimize sorting and assembly for recycling outcomes. Then we have recycling technologies, where we aim to maximize fiber recovery while minimizing degradation, and that's through both mechanical and chemical recycling processes. Some of them are listed here. There are quite a lot, so I'll spare you for the details. And then we have the traceability and product identification, where the development of smart sensors to create batch level data, where we at NIRITEX, among others, are part of this, to ensure that recycled outputs remain linked to their source materials, while also enabling more like precise fiber and product identification to support the correct recycling pathway. Next slide, please. Yeah, and that brings me to HUGEN as a use case. Because I work in NIRITEX, I chose to focus on the last presented area of traceability and product identification, where we at NIRITEX have developed our own locally embedded manufacturing execution system called HUGEN. That's named after Nordic mythology, for the ones of you who don't know, which is the name of Odin's bird, who flew out in the world to not only collect data or information, but also to analyze it and bring it back to Odin. So that is the reason for the name. As I said, it's a manufacturing execution system and it's already operational. And what it essentially does is that it captures and structures data automatically from the point of waste reception. We at NIRITEX, we are a textile sorter and recycler, and we receive about 50% of the Danish municipal textile waste. So it starts its traceability point at the point of reception and follows it through the pre-sorting and the automatic main sorting and through and onwards to the shipment for the next recycling steps. And HUGEN already operates on batch level traceability, and it captures and creates data points such as batch IDs, lot numbers, dates, locations for the processes, material information such as quantities and quality parameters, but also environmental data, which is the energy and water and gas usage throughout the process. So we know exactly how much gas, energy, and water was used at the point of the receival and pre-sorting, how much was used during the main sorting and the baling and so forth. So it's not a calculation, but it's a capturing of essential data for that point. That you can see here for the data content and DMPs is because through the STREP project, we also have a work package specifically focused on digital product passports within textiles, with an even more concrete focus on the recycling processes and how we can make that into component level information, also called a digital material passport. Next slide, please. Yes, so as part of this STREP project, we are working with our project partners to expand HUGEN to collect their data further downstream in the recycling process, which was the graph you saw on the previous slide, but to then also enable interoperable outputs for systems such as PROs or EPR system, where they need data to verify the quantities and have a compliance reporting. It could also be for the EU DPP registry when it's available, or other commercial platforms. And this is essentially because HUGEN it works with multiple data sources. So it can work with sensors, IoT, manual inputs, or for machines and equipment, which is what we have internally at NIRITEX. And then it collects it automatically or through manual input. It structures it to match what standardized data formats is needed for the export. Then it has the trace of the log updates, timestamps, who was accessing it, who can access what, and then the translation to map it to standards. Because of these, for example, an EPR system or an DPP registry, they might have slightly different, what you could call like data languages, or data formats or modules that how they talk to each other, which is this interoperability. So through STREP, we are developing Hugin further to be an enabler of this interoperability that is needed to actually ensure that something like the digital product passport or general traceability can actually improve the quality of recycling. So we can know what data needs to follow, what material, who needs what data at what time, when in the process does these data points develop, what quality does the next manufacturer in the line actually need to be able to ensure that the quality of the recycled material follows in their responsibility. Because if they don't have the right feedstock, they might have a really great process of creating great recycled quality of fibers or yarns. But if the start feedstock that begun the process is not correctly matched to the mechanical or chemical process, then that's where we have the first barrier. So it's essentially also helping to further the information of how we match the feedstock with the process demands. And that is how we are working through STREP with this case as Hugin, but also through further work packages such as on the DPP. And I can only encourage you to go on the STREP website to read a little bit more about the individual work packages that we're working with. This is quite a broad but important project, and follow the individual partners who are working hard on this. Yeah, that was it for me. Thank you very much.
Thank you. Thank you, Mette. So this brings us to the end of Pillar 2. Thank you all for your presentations. Before we move forward to the third and last pillar session that we have, I would just like to bring two questions to have a brief discussion with the speakers. So I'm going to start with one. Looking at your project, or from your project standpoint, how are you tackling public perception that recycled products can be of a lesser quality? And how do we shift consumer and industry mindsets to view these circular solutions as premium, high performance choices rather than just compromises for the planet?
Shall I start? This is actually a quite important question. It's for SNAC, it's actually about performance-based evidence, because it's very important to move the discussion away from recycled like compromises. It's more about performance-based evidence, and we would like to show that we have high performance insulations materials which meet technical, also environmental, and which is also important, very important, the economic requirements, because for sustainability, you need social, environmental, and economic issues you have to consider. In these performances, we are demonstrating in the real world on the real world demo sites. We in the project we combined the technical assessment with life cycle analysis, and also with cost related analysis with circular business models, and the preparation of the market uptake. But what is really important in my point of view is the communication issue. So it's about highlighting the benefits for the users. It's about stakeholder involvement. We have to show the technically the thermal performance, that it's comfort, durability, and it reduces the environmental footprint in the construction sector. This is actually, yeah.
Yeah,
from my point of view.
add to it because I completely agree, and it's really the very similar point to what we do at Strepor and the individual project partners. Because I think the communication point and what is important, even if you go to one-to-one recycling, so let's say garment to garment or fiber to fiber, or whether you go downcycling, is that key communication point is to say that we're not creating anything that doesn't have a quality that can actually compete with that of virgin materials, because otherwise there's no need to actually mass produce it to that point, because we would evidently just be producing waste, given the fact that it wouldn't be used or bought. And at Strep and Euritex, we are also doing extensive quality tests each time we have a fiber opening to test the fiber length, to see if that matches for the next one of the spinning process, but then also to know what is the split between the recycled content. So is it 20% recycled material that actually then with 80% virgin material gives us a 20% deduction in, because we also do with the LCAs, water usage, energy uses. If this is the transport, we have the hotspot to say, where is it in the virgin value chain versus the recycled value chain that these emissions are actually saved, and then where can we focus? And within STREP, we are also working on saying that instead of having virgin material, we are actually saying that then it's chemical recycled and mechanical recycled. So it might be 60% or 70% chemically recycled fibers, and then the rest be mechanical recycled fibers to then match, as Johanna was also saying, those quality tests. So we have a threshold, and that's essentially the communication that, as Johanna was saying, that we're also working a lot on, so people understand it, that what is actually then quality and how do we deem it.
To supplement also, all projects are trying to change this way of thinking by showing that circular solutions can actually be modern, efficient, high-performing. What makes Paraps also different is that we test our solutions in real industrial environments through the living labs. We are not only taking about sustainability in theory, we demonstrate renewable energy systems, industrial CVOCs, and all technologies under real operating conditions. So this helps industries and local communities to see real benefits, such as lower energy use, reduced emissions, better resource efficiency, and low operational cost. When companies will understand that circular solutions can also improve competitiveness and energy security, they stop seeing sustainability as a compromise. And also another key element is stakeholder participation through local green deals and co-creation activities. Industries, municipalities, researchers, and citizens work together. This creates trust and helps people feel involved in the transition.
Thank you. Thank you all for your inputs and contributions. We had another question here for Sin, but I'm afraid we won't be able to look into it now because we're a bit behind time. So we need to move forward with the next presentations. And then at the end, if we have some time and people are willing to stay for a couple more minutes, we will look into the second question, if that's okay.
Sure.
Thank you. Okay, then we're moving to the third and last pillar, the clean energy frontier, where we'll be focusing on next generation power and industrial efficiency. Again, we'll have 3 more EU-funded projects presented. We will start with Twain, who will be presented today by Nikolai Dimitrov, a senior researcher at DTU Wind and Energy Systems in Denmark. He works on data science, statistics, and machine learning applied to structural integrity, reliability, and operational decision-making problems in wind energy. Nikolai has more than 15 years of experience in the field, including technical work, teaching, supervision, and leading international research projects. Nikolai.
Yes, thank you, Raquel. Thank you very much for the introduction, and hello, everyone. So I will present you a project called Twain, which discusses wind farm control. Next slide, please. Yes, first, maybe a little bit of introduction of why we need wind farm control. Wind turbines, when they sit next to each other in a wind farm, they influence each other, and there's wakes which reduce the available power in the wind downwind from a turbine which is producing power. So the typical way of where where wind turbines work is that each of them tries to produce as much power as possible. So in fact, a wind farm is just a collection of wind turbines where each of them works in a kind of greedy way. So there's many indications and simulations that show that a more desirable strategy would be that we balance the way the wind turbines work within a wind farm in a more collaborative way, which means that maybe some of the turbines produce less power, or maybe they turn a little bit and modify their wakes. So they produce less power, but the overall combined output of the power from the wind farm is actually bigger. And this is one of the main topics in Twain, is to design such control strategies that could maximize the power output of a wind farm. But then we could also ask ourselves the question, is really power output the only valid goal in optimizing wind farm control? What about things like social aspects? Is our wind farm doing more or less noise? Maybe we want to actually have a wind farm which produces less noise, or maybe we also want a wind farm which is better for the biodiversity and does not, let's say, reduce the biodiversity by damaging wildlife. Next slide, please. So the project in itself has 5 parts or 5 main aspects. We work a lot on data-driven solutions for wind farm control, which also means that we need infrastructure which can handle this data and facilitate both the AI-based solutions, the machine learning, and simply hosting the data that you need to train these solutions. So this data infrastructure is the first pillar of the project. Then we have 3 technical topics. One is simulating the wind farm behavior. This is necessary in order to produce the wind farm control solutions we want. Then the second would be to compute the impact of these solutions. So if we design new ways of doing wind farm control, how does it impact the power production? How does it impact the revenue? How does it impact any other environmental aspects of it? Then finally, if we can design new wind farm control solutions, if we can compute their impact, we also need to decide what is our strategy in the end. So what do we implement in the field? What is our decision? So this decision support is the next technical aspect of our project. And finally, we have dissemination and communication. So of course, it is also good not to only have a result which could be used by the scientific community, but also multiplied in many other ways. And here, apart from taking part in forums like today and doing scientific publications, we also focus a lot on producing software, open access software that can be used by other users too. Next slide, please. A little bit on how do we use AI and machine learning and data. As I mentioned, a lot of the solutions we want to work with are data-driven and supported by machine learning. And of course, this requires a data framework. And this data framework, in order to ensure full accessibility, is implemented as an online platform. And since there are several partners that develop different parts of the solutions, and we want to also maybe users be able to come with their own solutions, it also means that we need a lot of interoperability and modularity in the system. So this also involves some work on data standardization. So we need to make sure all the data that we have are interoperable. And in addition to that, if it's an online system, and also we have wind farm control is also something which can be done remotely. So both of these topics mean that we also need to focus on cybersecurity. Then a bit more on the computations and how exactly do we use machine learning into our project. There's, I would say, 2 main aspects. One is really actually enhancing our computations. A lot of these wind farm behavior simulations, when they're physics-based, they take a lot of resources. So one way of reducing the amount of use of computation resources is to map these physics-based models to some, I would say, simpler and faster machine learning based models, sometimes called also surrogate models, and use those when we need to deploy our solutions. So this replacement of expensive physics-based models is one way we optimize our work. And the other thing is basically also combining different modules. Linking different types of tools is also one place where machine learning and in general data is helping us a lot. Next slide, please. Yes, so who are we actually? Who are the people behind the project? We have 10 partners, where 3 are universities. This is DTU, Technical University of Denmark, that's the coordinator, then TU Munich, TU Delft. We have several companies that own wind turbines and as a result very interested as end users. Then we also have research institutes and there, and then a Rambo consulting company. And last but not least, we also have SoftServe, who are a software company, also helping us with the implementation of the data infrastructure. Next slide, please. So just to give an overview of what kind of problems or use cases we're trying to solve. First, I think I mentioned several times, and I think this is also one of the key innovations in our project, is that we don't look only at power revenue, but we also look at the environmental and social aspects of wind turbines and how wind farm control can affect these social, let's say, social aspects of wind turbine acceptance, like noise and the impact. And then of adaptability to offshore, this is the offshore wind farms face some unique challenges. There's a much bigger arrays normally, so the wake effects in offshore wind farms are much more pronounced, which also requires some specific wind farm control solutions. There it's also a place where it becomes relevant to design the wind farm layout together with the wind farm control strategies in mind, which is actually our next use case. How do you design a wind farm that you know that it will have dedicated wind farm control in it? And then finally, the last solution is actually also the end of the line for wind turbines is life extension, end of life repowering. And then since our project works with controls, here the main idea with this use case is to find out what happens or how our control strategies could impact the way or the length of the wind turbine life, and then how long actually the turbines can be operated. So yeah, I think that's all from me. Thank you very much for listening.
Thank you, Nikolai, for joining us today and for presenting Twain here during this session. We'll move forward with the INFERNO project, which will be presented by Kafil M, Razeeb, who is the principal scientist and team leader at Tyndall National Institute in University College Cork. He's a principal investigator in Irish Photonic Integration Centre and funded investigator of Connect Centre, both funded by Science Foundation Ireland. He's also coordinator and PI of several successful EU projects and co-PI in many national and EU projects. He's a senior member of IEEE and chartered physicist and member of Institute of Physics. At present, is leading the Advanced Energy Materials Group at Tyndall. Razeeb, welcome.
Thank you so much, Raquel, for the kind introduction, and thank you again for inviting me to give the presentation. So can you please go to the next slide? Yeah, so I will talk about the INFERNO project that's from Tyndall's side I'm coordinating at this moment. So the title of this project is Recycling Industrial Wastage Through Thermophotovoltaics and Thermoelectric. By combining these two separate solid state technology, we would like to develop a hybrid systems that can be deployed in the industry setup. I mean, that is the main objective of this project. Next slide, please. So, okay, what is the problem? The problem is that all these high temperature industries, the processing industries like cement manufacturers, glass manufacturing industry, steel manufacturers, they use a lot of energy, and they are high temperature because some of their furnaces, they go to up to 2000 degrees centigrade. And there is no technology that is available at the moment to recover the waste heat, especially in the medium to high temperature processes. There are organic ranking cycles, but their efficiency is not very good. And and also, that they cannot be retrofitted with the existing setup in the industry, which is a big challenge. So what we aim in the Inferno project is that can we combine three kind of a technology together. One is a thermoelectric generator. Whenever you have a thermal gradient and you can generate electricity using these modules or these devices. Another is the thermophotovoltaic cells. You can imagine thermophotovoltaics just like a solar cell, but it is tuned to infrared region. Okay, so instead of the visible wavelength, these thermophotovoltaics, they can convert the radiation, the heat radiation, which is in infrared region, and then they can convert into electricity. And we combine all these two technology with metasurfaces and the reflectors, and we would like to develop a hybrid system that can be easily deployable in those industries like cement manufacturing plant or steel manufacturing plant or even the glass industries. The overall idea is that can we reduce some of the energy conversion or can we recycle some of the waste heat, and then convert directly into electricity, which can be usable by the industries for other purposes. Next slide, please. So the overall Inferno project, that it's divided into 6 work packages. Of course, we have the project management and the communication and dissemination work packages, and there are 4 technical work packages. And in these work packages, in the first one, we are trying to design a complete hybrid system. And in work package 2, our partners are developing the TPV cell, thermophotovoltaic cell, as well as the metasurface. In work package 3, we are developing the thermoelectric generator that can convert heat into electricity whenever you have a thermal gradient or temperature gradient. And then in work package 4, we are trying to integrate all 3 components together and develop a complete hybrid system that can be easily deployable and retrofitted in the furnaces, near to the furnaces of this industry. Next slide, please. Okay, so this is showing the Inferno development concept. As you can see, there are some nice photographs of the real devices. There is a photograph of the TPV cell, then the metasurface, then the TEG module, and then you can see on the very right-hand side, we are trying to take these technologies to the TRL level 6. That means we are now developing these hybrid system, and then we will deploy it into 3 different industry setup. One of them is a cement plant. Another one is the glass manufacturing industry, and the third one is the steel manufacturing industry in 3 separate jurisdictions. One will be in Ireland, another one will be in Germany, and the other one will be France. Next slide, please. So what is the overall impact? I mean, if you look at the part diagram the pie diagram on the right hand side, you can see that the concrete, steel, and aluminum manufacturing industry, these industries, they use over 20% of the global industrial energy, and all of them are high temperature process industries, and they are accountable for the 30% of the global CO2 emission from these industries. And in terms of economics, you can see that the heat recovery market, if you can convert this waste heat, because we cannot stop these industries, we do not have a better choice at the moment, beyond the concrete, steel, and the glass, So we can the overall market is over 52 billion, US dollars. And even if we can capture 1/3 of it, and we can reuse the waste heat, it will be about 17 billion. Even in Europe, only we are using about over 900 terawatt hour of heat that's being lost in these industries, and with 25% efficiency, I think we can meet this challenge. And the targeted temperature we are targeting in these industries are in the region of 400 degree to 800 degrees centigrade that are being wasted in the industries, and they do not have a technology to recapture this waste heat or to convert into electricity. So I think with this particular project, we believe that we can do a technological advancement, and we can, if we can deploy this in the industry setup, we can do some cost savings, and then of course the conversion of the waste heat into electricity is the benefit is paramount. Next slide, please. So the overall consortium, we are 6 partners, where we have 3 research institutes, Tyndall National Institute, Fraunhofer, and IFW Dresden. And then we have 2 universities, Technological University Dublin and University of Troyes. And of course, we also have a partner, which is F6S, who is looking after the dissemination and communication activities and help us to disseminate our work to the wider audience. That's it from my side. Last slide. I would like to thank you all, and if you have any questions, I'm happy to answer those.
Thank you, Razeeb. And now, last but not least, we'll move to Safer Vote, which will be the last project presented here today. And with us, we have Aldana Regina Chini. She's a project and an innovation manager at TIDAL, specializing in renewable hydrogen, power-to-X solutions, and industrial decarbonization, with a background spanning both industrial operations and European R&D projects. Her work focuses on bridging the gap between technology development and real-world industrial implementation. Aldana, thank you for joining.
Thank you very much. And well, hello, everyone. I'm very happy to be here, and I hope you are enjoying this webinar. I will present the C4 project. The title of this presentation is Investing in the Deep, Hydrogen from Seawater. My name is Aldana Chini. I'm a project and innovation manager in TIDAL Foundation. TIDAL Foundation is a technological center located in Spain. We aim to develop technology and innovation for the transport and the energy sector. So next slide, please. Well, what we do in C4 project? Well, C4 project is a co-founded project by the European Union and the Clean Hydrogen Partnership. And it aims to develop an anion exchange membrane, but the different thing and the challenge thing is that we are working directly with seawater. We are not working with type 2 water or like deionized water. We are working directly with seawater. And the challenge is, of course, to operate efficiently, selectively, and durably with direct seawater under a slight pH gradient for the membrane. And we are also tackling in this project the brine valorization to produce some valuable components and materials from the brine. Next slide, please. Well, an overview of this project. Well, this project is a research and innovation action. We start in a very low TRL, TRL2, and we will end it in TRL4. We started in September 25, and we will end this project in August 28. The duration, of course, is 3 years, and the budget that we have in is 4 million. The partners are 8 partners from 7 countries. We have 3 companies, F6S from Ireland, Hydrolite from Israel, and Stargate from Estonia. Also, we have 2 universities working in this project, Aalto University from Finland and Gdańsk University from Poland. And also we have 3 research and innovation centers, Fraunhofer IFAM from Germany, BTT from Finland, and CDOUT from Spain. Next slide, please. Well, the mission that we have is, of course, first of all, is understand the interaction of the materials and seawater, doing, of course, experimental and with machine learning tools. The idea here is to have an understanding of the corrosion, of the degradation of the materials. The second one is develop PFAS-free membranes, also durable PGM-free cathode and anode, and enhanced bipolar plate for seawater use. Also, within this project, we will design a single cell and a stack design for direct seawater electrolysis. And we will define protocols for defining, of course, performance and durability of these materials. And finally, we will design and also integrate this technology into a next zero liquid discharge flow field, trying to valorize the brine. Next slide, please. Well, how we do it? Well, we divided the workflow in 8 work packages. The first work package is this by BTT. BTT is the coordinator of this project. Then we have Success, the organizer of this webinar, as a dissemination and communication exploitation work package, as leading, of course, the work package 2. Then we have all the technical work packages inside the rectangle. Work package 3 is the identification and development of these suitable materials and components, and also is led by IFAM. Work package 4 is led by Gdansk University. We are scaling these materials and components into a stack level. In work package 7, we will try to understand through experiments and also computational studies the degradation, the aging of these materials, using, of course, seawater and using seawater with very corrosion environment. And in work package C, we will design and validate the single cell, and is led by Hydrolite. And work package 7, we will design also and validate the stack prototype, but in this case, in Stargate, because Stargate is leading this work package. And in work package 8, we will perform a techno-economic and also a life cycle sustainability assessment of this technology. We will try to see or study the different environmental impact against this technology developed against the conventional anion exchange membrane technology. Next slide, please. Well, the impact that we expected, well, in wave 1, we have these, is within the direction of the project. The idea here, of course, as I already mentioned, the aim of the project is to produce an anion exchange membrane, single cell and stack, able to perform durability with direct seawater feed in the cathode. The aim, of course, is to have a low amount of PGM, the platinum group metal, around, let's say, 90% less. We also will like here we will produce, of course, membrane electrode assembly with protective coatings for corrosion. And we will try to integrate this flow sheet into brine valorization, for brine valorization. Well, the idea into wave 2 to 135, we will try to reach a commercial level, of course, and have an uptake business of C4 Volt. The aim here is the technology will expand to the manufacturers, and we expect, hopefully, a manufacturing adoption in this moment of time, because in wave 3, beyond 2035, we expect, of course, have this technology developed, not developed, but is with a broader use. This is very important for Europeans and also for the sustainable use of resources, because we are tackling here the freshwater dependency and the scarcity. So the idea here is to produce hydrogen, a wider produce of renewable hydrogen from offshore production, and of course to impact the society with new jobs and in increasing, of course, the value chain of hydrogen. So I think that's all from my side. And the next slide, please. Well, I will also include here my email and my LinkedIn profile for you if you have some further question or also you wanted to connect. Thank you very much.
Thank you, Aldana, and thank you all for your presentations. And also thank you for the participants for staying with us as we're taking a bit longer than expected. So to close the pillar 3 session, I'll just like to bring some questions to our speakers. The first one, from your project standpoint, do you see the energy sources presented by the 3 projects as technologies to be intersected in a future integrated energy system?
Of course. Well, maybe I can start to respond to these questions. First of all, I think, of course, yes, because here in C4Bold, we are developing an electrolyzer. As you well know, electrolyzer use renewable sources, let's say renewable energy or energy, to produce hydrogen. To obtain renewable hydrogen or RFNBO hydrogen is the green hydrogen, let's say. And we need energy, and the energy also impact in the levelized cost of hydrogen very deeply, because if the cost of the electricity is around the 70 or 80% of the cost of the hydrogen. So if we want to develop this technology and also a broader adoption of this technology in order to produce and also order to produce green hydrogen and also to be competitive against the gray hydrogen from steam reforming, we need to reduce the price of this hydrogen, reducing the price of the energy. And in order to be competitive, we need renewable energy with a cheaper price. So in this case, the other projects aims to increase this energy efficiency of these renewable energies in order to reduce the amount of energy requirements. So in that case, of course, this is integrated. It's not directly integrated, but it's integrated because if we increase the energy efficiency and we increase the competitiveness of the renewables energy, of course we will achieve a very low price of energy, and then a broader adoption of the electrolyzer to produce green hydrogen.
Thank you, Aldana. Razeeb, would you like to add?
Yes, I think that's a very valid point, because if we want to solve this energy issue for everyone, as that's already Adrian mentioned, that's for running those electrolyzer, they will need electricity, and otherwise it won't be a green hydrogen production, if we end up using fossil fuel. So, I mean, the projects like TWAN and Inferno, if they can give them, renewable electricity, especially I can talk about Inferno, because there's a lot of waste heat in all kind of human processes that we take over, in our lifetime, in the society, in the industry. All these heat are being wasted, So even a small percentage of this waste heat, if that can be converted directly into electricity, then those electricity can be used for hydrogen production, to run this electrolyzer. There's a direct connection, But at the same time, I mean, the project like TWAN, I mean, that's for an intelligent way of generating electricity from the air. I mean that's very important as well. Because the question is that how we can minimize the loss, how we can be more efficient, and can we connect all the dots so we have a holistic, approach of this energy problem in our present society. Yeah.
Thank you. And just one more question. Innovation in renewable energy often requires a shift in mindset, right, from traditional industries. How are your projects actively bridging the gap between cutting-edge laboratory and data science and the practical, risk-averse realities of these heavy industries?
Do you want me to answer that, Raquel?
Yeah, if you'd like.
Okay, I can start. I mean, others can follow. Yes, there is a gap. There is a gap, and we see this gap, over the years. Like, say for instance, in some corner in the lab, we develop some technology, but there is not a direct connection. I think and commission now realize this gap, and you can see that there is more and more program where commission is suggesting us, the researchers, that can you start talking to the end user? Can you get involved with the society in terms of the adaptability, of the technology that you're developing? And I think it's a very good sign. It is a bit of work for us and for the social science people, and also the people who are doing the economics and the economic calculations. So I think we need to work together here. If we do not work together, then there is a disconnection between the technology and the deployment of the technology and with the end user as well. So say I can talk about Inferno. For Inferno project, we made it such a way that we are supposed to get involved with the end user. That means these industry early in the project. So we understand their boundary conditions, their problems and issues. Because we simply cannot develop a technology and go to the industry and say, here, hey, here is a technology. Do you want to use it? It's not going to work like that. So this early engagement with the industry and specifically the end users and the general public to understand their the boundary conditions and the mindset, that to use the technology, we need to understand that, and we need to work with them, and we need to make them educated that what are the downside of the technology, what is the upside of the technology, why the technology is for their benefit, and what it takes to take this technology to the market. We need to understand this whole value chain. And then and only then, I think, there will be a real change, we can make it a real change. Without these holistic approach, I don't think it's gonna work.
Yeah, from my side, I think Kafil was delivering a very, very good response. I totally agree with him. That's why in the case of C4 Bold, we are working very closely with industry. We have on board an electrolyzer OEM, is a Stargate. So, and also an hydrolyte as also producer of anion exchange membrane electrolyzer, and also producing anion exchange membranes for this kind of application. So involving these companies within the project is very key, of course, for them to the deployment of these technologies. Because if we don't have them on board, it's very difficult then to reach a commercial level of these technologies. So I think Kafil, I completely agree with him. And that's why also the Commission asked for project of very, very low TRL as C4 Bold to involve the companies, to involve the OEMs and all the value chain, sometimes depending of the TRL of the topics. So I think that's very, very, very important.
Yeah.
Thank you. Thank you for your contributions. We had one more question that was meant for the Pillar 2 speakers. We only have Joanna here, but Joanna, in case you would like to take that question, maybe we could answer it briefly before we close the session. And so the question was, transitioning to a truly circular built environment requires shifting away from deeply entrenched linear supply chains. From your project perspective, is there any market or regulatory hurdle you face when trying to scale these circular innovations? And how can policy better support the solution or the project solutions?
Okay. Actually, there are several hurdles we are facing. The first one and very important one is for the SNAG perspective, that the construction sector is strongly shaped and thinking in linear supply chains. So there are very conservative procurement practices which needs then a change in mindset. New circular materials often need not only to prove the environmental benefits, but also the technical reliability, the availability, certification issues, and last but not least, the cost competitiveness, which is very important. The second challenge is actually in the regulatory and in market acceptance. Bio-based materials may face uncertainty regarding standards. So therefore, also we have a standardization partner within the project. There are issues for certification, insurance, fire safety, durability, or long-term performances. So this actually may slow down the market uptake. That was the second part. I think that the policy, of course, could support these kind of solutions by creating stronger incentives for low carbon and circular construction materials in the construction sector. They can push the market. It's also for public procurement, for instance. And it might also be quite helpful to connect the innovation policy with other sectors like the renovation policy to foster the market uptake and market opportunities. But still there is quite the bio usage of bio-based materials in the construction, but also regarding the circular economy, there's quite far away, but step by step we will come closer to the goal. So that's actually from my point of view.
Thank you. Thank you, Joanna. And thank you all. Thank you to all the great speakers that were able to contribute to this session today. And thank you to all the participants who were able to join and endure with us throughout the whole time. Sorry, as we were a bit, we extended the time for a little bit, so sorry about that. Thank you, and feel free to reach out. The recording of this webinar will be shared on our social media. So it will be on the F6S iNovation LinkedIn page that will be promoted. That's where we have been promoted it. And just keep an eye out. Also important to say that this was an EU Green Week partner event. And we're very happy with the result. So thank you all and have a great week ahead. And see you.
Thank you so much. Thank you so much.
Thank you.
Thank you
Bye-bye.
so much
Thank
for
you.
the opportunity.
So much.
Bye bye. Have a great day.
You too.
Thank you.
Bye-bye.